Hi and welcome to this video on straight line, GCSE, Maths Made Easy. Now, the position of a point on a plane is determined using the distance between two fixed lines at right angles. So we have these two fixed lines at right angles, and we call this vertical line the y-axis and this the x-axis. So the horizontal is the x-axis, and the lines continue this way to the left and this way downwards. Upwards here we have positive integers, over here we have positive integers, and to the left we have negative, and downwards we have negative integers, and they are at regular intervals. We express the position as this position of a point as a distance from the y-axis and the x-axis, and we write the x first and then the y second in brackets. So for example, if we had this point and it's 2 along the x-axis, that's 2 units away from the y-axis, and it's 4 along the y-axis, positive direction, that's 4 units away from the x-axis, then we write the position of this point as xy as 2, 4 in brackets. Here I've just shown these two axes at right angles, and we're showing here that these are the positive units, these are the negative units, positive top, negative at the bottom at equal intervals, and we want to describe this point here. So it's x, 2 along the x-axis, 2 units away from the y-axis, so that's 2. And then secondly y, so it's 1 unit away from the x-axis, or 1 unit up the y-axis, whichever way you like to think about it. So xy, so it's 2 along the x and 1 along the y, point 2, 1. Here we're going to look at how we can find the distance between 2 points, and we're given the coordinates of the 2 points. A as 1, 1 and B as 4, 2. So A is 1 along, 1 up, 1 along the x, 1 along the y-axis. B is 4, 2, 4 along the x-axis, 2 up along the y-axis. So first of all, we draw a triangle as such with this point C making a right angle with these two shorter sides of our right angle triangle. And then we work out this difference in y and this difference in x. So sometimes this is called the rise and this is called the run. Okay, so we want to work out the rise and the run. And then we use Pythagoras. So Pythagoras says that AB squared equals AC squared, which is one of the shorter sides, plus BC squared, which is the other side squared. So here we've got 3 squared, 1, 2, 3 squared, plus 1 squared, here equals 10. So this side is the square root of 10, Pythagoras. In a general rule, so we can write it in this way. So if the coordinates that we're given for A are x1, y1, and for B x2, y2, then in general this AC is x2 minus x1, so that's this distance AC, and BC is y2 minus y1, which is the y coordinates, and then this is Pythagoras. The area for polygon. So if we want to find the area of a polygon, how we go about this is we draw some vertical lines down, and then we get this big polygon which is BCNO, and these little polygons BAMO and CNMA. So these two, we subtract these two smaller trapezia or trapeziums from this larger trapezium, that B, C, N, O. And that gives us our area of the triangle. This is the formula for working out the area of a trapezium. So it's half this side plus this side, the lengths, multiplied by this width. Okay, so if we were working out the big trapezium, so it would be the half of OB plus NC multiplied by NO. How to find the gradient of a line? We talked about the rise and the run, and basically the gradient of the line is the rise over the run, the increase in y over the increase in x. We can generally do this if we're given 2 points on the line, or if we're just given, if it starts off from 0, the origin, and goes up to a point, we can use that, form our triangle, our right angle triangle, and get our rise over run. So the gradient of a line is the rise over the run, or the increase in y, which is this side here of our triangle that we're going to form, divided by this difference in x, or the increase in x. If we know 2 points, this Q is 2, 1 and R is 4, 2, then we can work out the gradient of the line using these coordinates that we're given. So the gradient of the line would be the difference, or the increase in y, which is this length, which is 2 minus the 1, divided by the increase in x, which is 4 minus 2. So in this case, the gradient is 1 over 2, so half. If the gradient goes in this direction, so it's going upwards from right to left, this is a negative gradient. Remember when we were doing this one, this goes upwards from left to right, that's a positive gradient. So negative gradient, and we're given 2 points on the line, or we can work out 2 points on the line. Then we can work out our negative gradient as increase in y, which is the rise, divided by the increase in x, which is the run. So we make a little triangle. The increase in y divided by the increase in x equals our gradient. So the increase in y is 1.5 minus 2. Here we are. And the increase in y is 0 minus minus 2. So don't forget this little minus here. So 0 minus minus 2. 1.5 minus 2 becomes minus 0.5. 0 minus minus 2 is 2. So this is minus 1 over 4, which is minus a quarter. If we consider the equation y equals x, this is a straight line passing through the origin, which is this point here, 0. And the gradient of the line is 1. If we consider this, y equals 2x, this line here, then the gradient of that line is 2. So generally speaking, if we look at these two, we can represent a general equation where if a straight line goes through the origin, y equals mx, where m is the gradient. So this is the gradient 2. So if it was 3, it'd be steeper. Okay, and that's only true for points that go through the origin. Now here we've got the line y equals 2x, and it's parallel if we move it up. So let's try and move that up. Move the O back, just 1 minute. So we're going to move this line up, just keeping it parallel to this position, where it crosses the y-axis at 2. Then the equation becomes y equals 2x plus 2. Okay, let's move that back. So y equals 2x, y equals 2x plus 2. So remember this was y equals mx if it went through the origin. If it goes through the y-axis at a point, then it's plus 2. If it was over here, it'd be plus 1. So this would be y equals 2x plus 1. Now, So let's move this back to plus 2, y equals 2x plus 2. Lines are parallel. So generally speaking, we can have this equation, this general equation, y equals mx plus c. So the gradient of the line is m, and it cuts the y-axis at 2, and that's the distance c from the origin. So this is y equals mx plus c, m being the gradient, and c being where it cuts the y-axis. If we got two perpendicular lines, so the general equation of this line is y equals mx plus c, then the gradient of this line, which perpendicular at right angles to it, would be minus 1 over m. Okay, so this is very important. So if somebody asks you about two lines that are perpendicular to each other, so the perpendicular would have a gradient of minus 1 divided by m, or the negative reciprocal. Okay, and if we had this m and the m here, say we call that m dash of the perpendicular line, m multiplied by m dash equals minus 1. Here we're asked the question, find the equation of the line perpendicular to the line y minus 3x equals 2 and passing through the origin. So we're going to use the equation y equals mx. So the gradient of the perpendicular line, the gradient here is 3. So if we rearrange this into y equals mx plus c, or y equals mx, you can see that this going to the other side of the equal sign becomes plus 3x, gradient of 3. So the negative reciprocal is minus 1 over 3. So the gradient would be minus 1 over 3, and y equals minus 1/3 x. If we rearrange that, 3y plus x equals 0. Find the equation of the line passing through the 2 points minus 1, 2 and 2, 4. So those are our 2 points. First of all, work out our gradient. So the gradient will be, like we said, y2 minus y1, and here x2 minus x1, and we get this as the gradient, 4 minus 2, 2 minus minus 1. So our gradient is 2 divided by 3. Now we know that the general equation is y equals mx plus c. So choose one of these points and plug it into our general equation. So we're going to use this point. This is x, this is y, remember. So 4, which is here, equals 2/3, which is our m, multiplied by x, which is 2 plus c. Okay, so 4 equals 4/3, 2/3 times 2 is 4/3. 4 equals 4/3 plus c, and we can work out c by taking 4 minus 4/3, which equals 8/3. So our c equals 8/3. So then our equation becomes y equals 2/3 x, 2/3 being mx, plus our c, which is 8/3. If we rearrange, we get this, and if we rearrange again, we can get that. So all these are the equations for the line passing through the 2 given points.